Hi students, in this class we will solve a numerical problem on the inductance of three-phase transmission lines. So the diameter of the conductors is given, it is 20 mm diameter. The conductors are regularly transposed, so in all the three phases you will be getting the same inductance. And in the first case the conductors are placed at the corners of a triangle with a 4 meter and 5 meter and a 6 meter sides. And in the second case, the three conductors are placed at the corners of an equilateral triangle. And in the third case, they are placed in a horizontal plane. Now see the first case. The diameter is 20 mm. The sides of the triangle are 4 meter, 5 meter and 6 meter. Now this is side D1 and this is D2 and this side is D3. And D1 is equal to 400 mm. It is 4 meters, or you can write 400 centimeters. D2 is equal to 5 meters. So this is equal to 500 centimeters. And D3 is 6 meters, or it is equal to 600 centimeters. And the radius is given, R is equal to, the diameter is given, it is 20 mm, or radius is equal to 10 mm, or this is equal to 1 centimeter. Our inductance formula is equal to 2 into 10 raised to minus 7 log with the base e. Log with the base e is same as natural logarithm. In the calculator you can use the function ln. Log dm divided by ds. And dm is the mutual distance and ds is the self distance. And in our problem, we have one conductor per phase, so this ds will be equal to r dash. R dash is equal to 0.7788 into r, which is equal to 0.7788 into, in our case, r is equal to 1 centimeter into 1. This is equal to 0.7788 centimeter. Now I'll find out dm. dm is equal to, we have three sides. D1, D2 and D3. These are the distances between the phases. We have three terms, so you find out cube root. If we have 6 sides or 6 distances, then you put 6th root. It is very easy to calculate. So in our case, this is equal to, this is the mutual distance among the phases. The distances are 400 centimeter, then 500 centimeter and 600 centimeter. And this will be 493.24 centimeter. If you put dm in centimeter, ds should also be in centimeter. So both the distances should be in same unit. And here inductance is equal to 2 into 10 raised to minus 7 natural logarithm or log with the base e. What is our dm? 493.24 divided by, our ds is equal to 0.7788. And this is equal to 1.29 into 10 raised to minus 6 Henry per meter. The unit of inductance in our calculation will always be Henry per meter, because in every calculation we assume that our conductor has a length of 1 meter. So if you want to find out the inductance of 10-meter length conductor, you multiply this value with the 10. We have to calculate the inductance per kilometer in our problem. So this is equal to 1.29 into 10 raised to minus 6 into 10 power 3 Henry per kilometer. And this is equal to 1.29 millihenry per kilometer. And in the second case, the conductors are placed at the corners of an equilateral triangle. So these sides are equal. This is D, all sides are equal. And the problem D is given as 5 meters, or this is equal to 500 centimeters, or R is equal to 1 centimeter, and in this case the distance is 500 centimeters. Again the formula is same. Inductance is equal to 2 into 10 raised to minus 7 log with the base E dm by ds. We have one conductor per phase, so the ds is equal to r dash. If we have more conductors, just like dm, ds will also be calculated. And this is very simple calculation, 0.7788 into r. This is equal to r is equal to 1 centimeter, so it is 0.7788 centimeter. Now we have to calculate dm. dm is equal to, we have three lengths here, d1, d2 and d3, all are same. As you have three terms, it is easy to remember, you put 3 here. You find out the cube root. If you have 6 conductors, you put 6 here. You find out the 6th root. So this is equal to the cube root of d cube. This is d. In our case, d is equal to 500 centimeter. So now you can find out the inductance. 2 into 10 raised to minus 7 log dm by ds. dm is equal to 500 by ds is equal to r dash, which is 0.7788. And this is equal to 1.29 into 10 raised to minus 6 Henry per meter. So this is equal to, we have to calculate the inductance per kilometer, 1.29 10 raised to minus 6 into 10 power 3 Henry per kilometer. And this is equal to 1.29 into 10 raised to minus 3 Henry per kilometer, or you can write this as 1.29 millihenry per kilometer. This is our second case. And in the third case, the conductors are placed in a horizontal plane where the distances are given as, this is d1 and this is d2. Let this distance be d3. This is 400 meters. d1 is equal to, 4 meters, so it is 400 centimeter. 4 meter. This is also 4 meter. So d3 will obviously be 8 meters. And the inductance formula is same. 2 10 raised to minus 7 log dm by ds. This is equal to 2 10 raised to minus 7. What is our dm here? dm we have to calculate. Again, the ds is same as we have one conductor per phase. ds is equal to r dash, which is equal to, just like we calculated in the previous case, it is 0.7788 centimeter. And the dm we have to calculate is the mutual distance among the phases. We have 3 distances here, so you put cube root, d1, d2, d3. The distances are 400 centimeter, Then second one is also 400 centimeter. And the third one is 800 centimeter. If you put ds in centimeter, dm should also be in centimeter. So these two units should be the same. And this is equal to 503.96. So inductance is equal to 2 into 10 raised to minus 7 natural logarithm dm, which is equal to 503.96, divided by ds is equal to 0.7788, and this is equal to 1.2945 into 10 raised to minus 6 Henry per meter. We have to calculate the inductance per kilometer length. So it is 1.2945 into 10 raised to minus 6 into 10 raised to plus 3 Henry per kilometer. This is equal to 1.2945 into 10 raised to minus 3 Henry per kilometer, which is equal to 1.2945 millihenry per kilometer. This is the inductance per kilometer length. If you want to find out the inductance for a 10 meter length, you can multiply this inductance with 10.